All right, we've been identifying the different parts of electricity, things like current and voltage and resistance, and talking about electrical power. Now let's talk about the interesting things, like how circuits work. A circuit is a path through which electricity flows, and in order for the electricity to move through it, it has to make a complete loop. It has to begin and end at the same place, usually at the battery. We've got a standardized sort of circuit diagram system where we use the same symbols to represent things. So the straight lines are wires. A zigzag like this would be a resistor. A zigzag in a circle is a light bulb. These two parallel lines, perpendicular lines to the wire indicate a battery. It's basically the positive versus the negative side here. And then this is a switch that can be open or shut to activate the circuit. So there are two different types of circuits. The first type is called a series, where everything that's in the circuit is built into the same path. It all just goes through every piece of it before returning to the battery. These work great because they're so simple, but unfortunately, if one of these burns out, the whole thing fails. You might remember like really old Christmas tree light strands with, you'd have hundreds of tiny little light bulbs on it. If one bulb burnt out, all the bulbs went out. And so you'd have to replace one bulb at a time to try and find the burnt out one. It was really tedious. More modern ones have two wires, and so we don't put all the light bulbs on the same circuit. We let the current sort of be able to dodge around them. And so if one light bulb burns out, the whole thing doesn't go out. Okay, so the current stays the same throughout the entire circuit. The total resistance of the circuit is equal to the sum of all the individual resistances. So if this one's 2 and 3 and 4, then the total resistance would be 2 plus 3 plus 4, 9 ohms. And then the total voltage is the sum of the individual voltages of the batteries. We could have like a 9-volt battery plus a 1.5-volt battery or whatever. You just add them together if you have more than one battery. So let's say we have an example. A 9-volt battery is connected to 4 light bulbs with resistances of 4, 2, 5, and 7 ohms. Find the current. First we need to find the total resistance. Because it's in series, it's just the sum. 4 plus 2 plus 5 plus 7. 6 plus 5 is 11, plus 7, 18 ohms. And we're told that the voltage is 9 volts. It's a 9-volt battery. So we know that voltage equals I times R. This is sum of R, that's why it looks so funny, but still just V equals I times R. So I, the current, is V divided by the total resistance. 9 volts divided by 18 ohms, 0.5 amps. Not too hard. And usually I'd have you guys actually sketch the circuits and stuff too, but that doesn't work well with Google Forms, so we're skipping that this year. Okay, the other option is what's called a parallel circuit. Parallel circuits look more like ladders, where each individual element is isolated on its own little branch. There's multiple ways for the charge to move through, and so if one of them burns out, the rest of them are still fine. One part failing doesn't cause the entire circuit to fail. The total current would be the sum of the currents traveling through each branch, and the total voltage is the same throughout, so like whatever the voltage the batteries give you. The total resistance here is a bit trickier to calculate, because this is more like, this is actually kind of like our lens calculations, where it's the inverse. 1 over the total resistance equals 1 over R1 plus 1 over R2 plus 1 over R3, or however many R's there are. And then you have to flip it back right side up to solve for total resistance. So, another example. Let's say we have a 9-volt battery still, and 4 light bulbs in parallel with 2, 4, 8, and 16 ohms. Find the total current. So, 1 over the total resistance is 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16. I'm going to go ahead and move all of those into sixteenths. So it turns to 8 sixteenths plus 4 sixteenths plus 2 sixteenths plus 1 16th. That's 15 sixteenths. Then I have to flip it upside down to find just R. 16 over 15, 1.07 ohms is the total resistance. Voltage is still 9 volts from the battery. So again, I equals voltage divided by the total resistance. 9 divided by 1.07 gives me 8.41 amps as the total current. Okay, so you're going to be doing a couple of these, 2 in series and 2 that are in parallel. They're not terribly hard. I do recommend trying to work it out, the fractions on paper, instead of just plugging them into a calculator, just because it's easier that way for me. And don't forget to do that flip at the end, because you need to find the total resistance, not just solve it for the inverse of the total resistance. But anyway, so that's it for the notes today. We'll have a nice long weekend and pick this up again on Tuesday. All right, thanks. Bye.